Hi everyone, am I audible? Yeah, guys, am I audible? Okay, good. Before we start, please, if you have any doubt regarding the third or fourth exercise, please feel free to ask. We will only start once your all the doubts are clear. So please feel free to ask any question, any doubt regarding the third and fourth exercise, which were basically integration using trigonometric identities and integration using some particular function. If anyone has doubt, just raise your hand so that I get to know whether I have to move ahead or not. If you have any doubt, just raise your hand. So I will wait. Otherwise, we can start with the next concept. Okay, chalo then. Cool. Let's start with the next concept, and next topic will be integration by partial fraction. So we got a gist of how to integrate a function. Integration is the key points are, I will just revise the summary once. Integration is the reverse process of differentiation, right? So all the functions whose differentiation can be done, right? All the functions whose differentiations can be find out. And let's say for a function fx, its differentiation is gx, some other function gx. Then we can always integrate gx back to fx, right? And using this, we have created some list of formulae, right? Basic formulae. And using that, we have tried to solve a lot of questions. And after this, after just a minute. Oh, yeah. So after applying these basic rules, then we got to integration using trigonometric identities and integration using particular functions, which were basically a part of integration by substitution, right? So we have understood one portion. I can divide whole of indefinite integration into three portions, right? And in fact, we must have divided that somewhere. I don't know where, but somewhere we must have talked about it. Just a minute. Okay. Okay. Yeah. See, so methods of integration, we can divide the whole indefinite integration into three parts. First was integration by substitution, and told you that this is the most important one because it will be used even in integration by partial fraction and integration by parts, right? Now, the second part of or second phase of integration starts today, which is integration by partial fraction. But before we reach to whole of this theory of partial fraction, how to integrate partial fraction, I would like to explain few terms, few mathematical terms, and few expressions which you may know or may not. But they have taught you, we have taught you like in 11th about these expressions. But let's first revise. Let's first understand the theory what we are talking about. Okay, then we will move on to integration. If you understand this theory, which I will be going to cover in the next 15 to 20 or 30 minutes, then we will be able to solve the whole exercise very clearly and very, efficiently, right? So this whole process can be very easy if you understand what I'm telling you, in the next 15 to 20 minutes. So before we reach to integration by partial fraction, let's understand a few terms, and let's start with rational functions. So before even rational functions, I would like to tell polynomials. I would like to talk about polynomials. So can somebody tell me what is the definition of polynomial? What are polynomials? How do you define polynomials? either you can give a definition, or you can tell me your understanding or your concept of polynomials, or you can just give me an example. You can do anything, but like soon, quickly. We don't have much time. So if you have any understanding about polynomials, you can please share that with me. Okay. Algebraic expressions, correct, Chavez. I mean, partially correct. These are algebraic expressions, but I mean, there are a lot of algebraic expressions, but every algebraic expression cannot just simply be said polynomial. They, all the algebraic functions which are called polynomials must follow some rules. Now I'm interested in those rules. Okay, let me start. So first of all, how are your normal polynomial looks like? You will give every polynomial a name. Okay, it can be px, it can be fx, it can be anything, right? So this is the name, and this basically is your variable of polynomial. Variable of polynomial. Now, your polynomial can contain as many variables as the expression wants, but in our syllabus, we will only we will only encounter polynomials in one variable. Okay, so most of the times you have seen, and you have been seeing these expressions for like 3, 4, 5 years now. So most of the times you have seen like all the functions are written like fx, gx, px. Why? Because f, g, p are the names of the function, and inside brackets, inside parentheses, we basically represent the variable of that polynomial. So if I'm writing fx, it means that I'm about to write an algebraic expression in x, right? Now, some algebraic expressions are special. What makes them special? Why am I saying this? And most importantly, that what is the quality that makes them special? So some algebraic expressions are special and they are known as polynomials. But before writing that, I would like to tell you the general form of polynomial. Okay. So general form of polynomial can be like this. But if I just note them, I would explain everything. Don't worry. If you are not able to understand what is written here, then this is a0 x to the power n plus a1 into x to the power n minus 1 plus a2 into x to the power n minus 2 plus a n minus 1 into x plus a n. Now understand this a0, a1, a2 up to a n, right? These are constants. These are constants. A1, A0, A2, they must contain some value. They will be having some value. For a particular expression, these constants can be defined very easily. But understand the powers of x. So these are, every term contains x, right? This, barring this, every term contains x. So all such expressions, or all such algebraic expressions in which the power of variable must be a whole number. Now, whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So whatever your algebraic expression is written, if you want to check whether that algebraic expression is a polynomial or not, then you just have to focus on the powers of variable, right? However variables involved in that particular expression, right? The power of the every variable must be a whole number. As long as this condition is satisfied by a particular algebraic expression, that particular algebraic expression can be called as a polynomial. For example, we'll start with some example and you will get it very quickly. So let's say I'm writing a polynomial and the name of the polynomial is px. It means that the variable of polynomial will be x. And if I write x like this, x cubed plus x square plus 4, right? Now you see, the variable is x. You just check what is the power of the variable. In one term, which is x cubed, the power of the variable is 3. And in another term, in which x is involved, the power of x is 2. We don't have anything, we don't have any problem with 4. because 4 basically can be written as 4 into 1, and this 1 can be written as x to the power 0. So all the constants basically follow this rule that if you multiply a constant with 1, and you can always write the 1 as x to the power 0. So it means that this is also following this rule that the power of variable must be a whole number, because x to the power 0 is, again, 0 is a whole number, right? So we just have to check all the variables, basically, power of variables. And if all those powers are whole number, then we can say that this particular algebraic expression is a polynomial, right? And the highest power of variable is known as degree. So in this case, the degree of this polynomial is 3. Now, for example, let's take another polynomial, and let's say the name of the polynomial this time is qx. Okay, sorry, I'm not taking a polynomial, I'm just taking an algebraic expression. You will tell me whether this is a polynomial or not. Is this a polynomial? Yeah, guys, is this a polynomial? Correct, Austin. Why? Why, Austin? The powers, what's the problem with powers? Like, tell me exactly the problem with powers.
They're not consecutive.
Okay, let's consider. There are 3 terms, right, which contains x. First term contains x to the power 7. So what is the, I mean, is the power of x a whole number? X to the power 7. So 7 is a whole number, right? Then again, 2 is also a whole number. 1 is also a whole number. So this is a polynomial. Why is, I mean, why will this not be a polynomial? This is a polynomial, certainly a polynomial of degree 7. Guys, did you get this? Now, if I write root x plus 1 by x plus x cubed, this is not a polynomial. Why? Because if you change root into the power, right? If you change root into the power, then this becomes x to the power half. And half is certainly not a whole number. And again, this term is also violating. This is nothing but x to the power minus 1. So in one term, the power is half, and in other term, the power is minus 1. That is why this is not a polynomial. Just give me a minute. Hanji, is it clear that why this is not a polynomial? And if some particular algebraic expression is not a polynomial, then its degree does not exist. You can only define degree once it is a polynomial. If an algebraic expression is not a polynomial, then its degree is not defined, right? And as soon as one term violate, for example, if we did not contain 1 by x in this particular expression, or if we did not contain root x in this particular expression, then also this expression would not have been a polynomial, right? Because if the rule violates even one time, then the particular expression cannot be called as a polynomial, right? So polynomials are simple. Simple. Just observe the power of variables. If everywhere, wherever the variable is used, everywhere the power of variable is whole number, then you can safely say that that particular algebraic expression is a polynomial. right? If you want to ask anything, please feel free to ask. This is your time. Okay. In that case, let's move forward to next thing. Rational functions. So what are rational functions? Very easy. Do you know? Okay. So let's try it this way. Okay. We know whole numbers, right? Right. We know whole numbers, and we also know rational numbers. Do you remember how did we define rational numbers first? First time when you hear about rational numbers, how did you define rational numbers? Numbers that can be expressed in the form of p by q. Very good, Austin. Where p and q are whole numbers and q is not equal to 0, right? Also remember this definition. Yeah. So all the rational numbers can be defined very easily as p by q, right? P by q means all the numbers which can be described in terms of fraction are known as rational numbers. Similarly, just similarly, now understand rational function, right? So a function fx is known as a rational function if fx can be defined as px by qx, where px and qx are polynomials. Understand this. Now, first of all, understand this in layman terms. What is this? This is nothing very smart thing. I mean, this is nothing fancy. Very easy stuff. We are saying that as you defined rational numbers, so what were rational numbers? Rational numbers were a ratio of whole numbers, right? Rational numbers are those numbers which can be defined as p by q, where p and q were what? Whole numbers, right? And q cannot take the value 0. Now, rational functions are defined similarly. If you take the ratio of two polynomials, then that ratio is known as rational function. For example, if you write a function like this, fx is equals to x minus 1 divided by x square plus 1. Now see, this is also polynomial. In numerator, there is a polynomial. In denominator, there is a polynomial. X minus 1 is a linear polynomial. Linear polynomials are those polynomials in which the degree is 1. And this is a quadratic polynomial because the degree is 2, right? Now this fx can be defined as a rational function. Now let's see some more rational functions. This is also a rational function. Then this is also a rational function. So all of these functions can be defined as rational functions. बहुत ही simple. Rational functions are those functions or basically ratios of polynomials. Simple, right? You can ask me if you want to ask anything. Okay. Now, in that case, let me come to my next point, which is a very important point, by the way. So, सबसे पहले मेरी बात समझो एक बार मैं क्या बोल रहा हूँ ना. So let's say we have a polynomial of degree 100. It can be anything. I will take another example as well. But first understand with this example. Okay. So let's say, or rather than 100, let's take 6 for easy. I mean, for easiness. Let's take the power of the polynomial as 6. So let's say we have a polynomial of degree 6. Okay. Now you can write any polynomial. For example, let's say I am writing this polynomial. I can take any polynomial, by the way. I will again emphasize on this. I can take anything, whatever you want. Just the degree need to be 6. Okay. So if I take a polynomial of degree 6, right? This polynomial can be divided into 3 quadratic equations. If I factorize this particular polynomial of degree 6, then this will definitely, and I'm using this word again, definitely, this will be definitely, this particular expression can definitely be broken into 3 separate quadratic expressions. And if you multiply them, then you will get the same expression, x to the power 6 plus x to the power 5 plus x square plus 10. In fact, take any polynomial of degree 6, and that polynomial can further be broken down into multiplication of 3 quadratic expression. Okay, hear me out once more. If I take a polynomial of degree 100, let's say this is the polynomial. X to the power 100 plus 1. Then this can be broken down into 50 quadratic expressions, multiplication of 50, product of 50 quadratic equations. Now, what do I mean by this? Again, I will take one more example here. All I'm taking is the even degree right now. Let's take an odd degree. Let's say I have this x to the power 7 plus x to the power 5. This particular expression, x to the power 7 plus x to the power 5. Now the degree is 7. So this can be broken down into the multiplication of 3 quadratic expression and 1 linear term. Now understand this. The smallest equation into which a particular polynomial can be broken down is quadratic expression, which means अगर आपके पास कोई भी पॉलिनोमियल है, आप उसको ब्रेक कर सकते हो और उसकी सबसे छोटी यूनिट होगी क्वाड्रेटिक एक्सप्रेशन. तो अगर मेरे पास कोई डिग्री 10 वाला पॉलिनोमियल है, तो आई कैन ब्रेक दैट पॉलिनोमियल ऑफ डिग्री 10 into 5 quadratic polynomials. Now let's say if the degree is 11, then what? Then 5 quadratic equation, 1 linear equation. If the degree is 12, then 6 quadratic equations, right? So this can be further broken down into something like this. Understand this. 1 quadratic equation. I don't know what are the values of a1, a2, a3. There will be something, certainly. And I am not interested in that right now. I mean, we can definitely find them out, but we will not tell you to find them out. Don't worry. We are not saying, but we are just telling you the concept that every particular polynomial can be broken down into pieces of quadratic equations, right? So if I write this, then it means it will be something like this: 1 linear expression and 3 quadratic expression. Similarly, c1x square, c2x plus c3, and similarly d1x square plus d2x plus d3. Right? So this was an important task. Why did I tell you these things? Now all of this will be used. Everything whatever I have taught you by far will be used. Now understand the concept of partial fraction. Let's come to the partial fraction now. Hanji, isme koi bhi doubt? If any doubt, please feel free to ask, because everything will be used. I'm writing this rule here, by the way. Okay, cool. So every polynomial can be broken down to multiplication of multiple quadratic / linear एक्सप्रेशंस। बस इतना ही बोल रहे कि भाई अगर कोई भी पॉलिनोमियल होगा तो हर पॉलिनोमियल को आप तोड़ सकते हो, ब्रेक कर सकते हो। एंड हाउ विल यू ब्रेक दैट पॉलिनोमियल? इनटू द स्मॉलर यूनिट्स ऑफ quadratic expression, right? Now let's come to the picture of quadratic equation. Just wanted to tell you guys, I don't know whether you remember this or not. So if you have, let's say this is your quadratic expression, ax square plus bx plus c is equals to 0. You want to find out the roots of this quadratic equation, then you know what to do, right? If not, then I'm telling you what to do. I mean, I am just revising the concept of class 10, where we studied how to find out the roots of a quadratic expression. So how did we find that? Let's use quadratic formula directly. So first we will find out, first we will go for d, right? So first, if d is greater than equal to 0, then roots exist. If d is greater than 0, then the roots will be distinct. If d is equals to 0, then the roots will be same, equal, right? But if d is less than 0, then roots does not exist. Now understand, what does that mean? If roots exist, this particular quadratic expression can be further divided or can be further factorized into two separate or two linear expressions. This can be further factorized into multiplication of two linear expressions. And if you are not able to find out the root, it means that you cannot further factorize this particular expression. You can't factorize this. In that case, you just have your ax square plus bx plus c, whatever your that expression is, right? So if root exists, it means, for example, if you find out the roots of this, then you will get the roots as 1 and 2. Why you are getting the roots as 1 and 2? Because you can factorize this particular expression like this, x minus 1 and x minus 2. If you put x minus 1 equals to 0, then x is equals to 1. If you put x minus 2 equals to 0, then x is equals to 2. So that is why the roots are coming out as 1 and 2, because you can factorize this into two linear expressions. But if you can't factorize this, then obviously you don't have roots, right? Okay, chaliye ji, let's go ahead. These were the base things. This was the base that we need to cover before we reach to partial fraction. Now let's understand what is partial fraction. Okay. So what are we basically solving here is, now let's, I mean, we gathered the required information. Now let's come to integration. Let's just put it, all the information that we have just studied, put it aside for like 2-3 minutes. Now let's come back to the integration and also understand what we are basically trying to understand today. I mean, what we are going to solve today. So integration by partial fraction. Integration by partial fraction. First, understand what are the type of expressions that we are going to integrate here. So we can integrate any rational function. We are talking about integration. Today, we are talking about integration of rational functions. You will encounter a lot of rational functions, by the way. Very important to understand the integration of rational functions. We can integrate any rational function. I would like to again emphasize this. We can integrate any rational function, anyone. And you know what is a rational function, right? Rational function is a ratio of polynomials. So if you see a polynomial in numerator and if you see a polynomial in denominator, then please don't worry about that. You definitely can solve this expression. Definitely. I mean, I did not use the word definitely while solving questions from integration by substitution, because integration by substitution is tough. You will need a lot of practice. You will need a significant amount of practice to master that topic. But integration by partial fraction is pretty easy, straightforward. Just be with me and understand the concepts, understand these small things, and then we will reach to a formula. If you use the formula correctly, you will be able to solve every question from integration by partial fraction, right? So we can integrate, again emphasizing on the fact that we can integrate any rational function. Now, how to integrate that function? Okay, so integration of rational functions and can integrate any rational function. Now let's understand the rules. How do we integrate a rational function? So any rational function will be of the type. So we are basically trying to find out this. Consider I is equals to, which is integration of px by qx, right? Where px and qx both are polynomials, right? And let's say we also know the degree of px and qx. Let's take the degree of px as m and degree of qx as n, right? The degree of px is m and the degree of qx is n. Degree means the highest power involved with the variable. Okay. Now, so first case, either this m can be greater than or equal to n. Either this m is greater than n or m is equal to n, right? So if this is the case, m greater than equal to n, then in these cases, the rational function is known as improper rational function. यार फ्रैक्शन में भी ऐसे ही होता था, अगर तुम्हें याद हो, मुझे पता नहीं if you remember that improper fraction माने ये 4/5 is a proper fraction, but if you talk about 7/5, then this is an improper fraction. So अगर if numerator is large than denominator, so we say that the fraction is improper, right? Same logic. If the power of numerator, if the degree of numerator is either equal to or larger than the degree of denominator, then we say that this particular rational function is improper. Improper rational function. So in case of improper rational function, please first divide the polynomial which is present in numerator by the polynomial in denominator. So for example, if the numerator is a polynomial of degree 3 and denominator is a polynomial of degree 1, then we will first divide the polynomial of degree 3 by polynomial of degree 1, right? And after dividing, we will get some divisor, some divided and some remainder, right? So we can change this particular expression px by qx like this, something like this. Okay, there will be some expression, let's call that fx, right? This will be your what do we call this, by the way? Divisor or dividing? I forgot. I mean, if we are dividing 13 by 4, this was divisor, right? And this is divided. Please correct me if I'm wrong. Sorry. This is quotient. I forgot. Oh my God. What is 13? Okay, tell me that. What is 13? Quotient or divisor? Quotient, right? Yeah. So this is divisor, this is divided, and this is remainder, I guess. Yeah. So 3 is quotient, correct. वही मैं सोच रहा यार कि गड़बड़ तो हो रही है, कुछ सही सा तो नहीं लग रहा है. हाँ, 3 is quotient, correct. And this is your divisor, sorry, dividend, right? And this is divisor, correct. अब ठीक है, चलो. तो हम ये बोल रहे हैं कि अगर देखो 13/4 लिखा है ना, अंडरस्टैंड दिस. if it's written as 13/4, which means that if the power or if the degree of numerator is larger than degree of denominator, then please first go through long division. By long division, convert it like this: 3 quotient plus remainder by divisor. Right? And then proceed with the question. So first, if the rational function given is improper, then please change to proper rational function using long division. So after long division, you will get these two things, quotient and remainder. Please write them like this. Okay. And if the rational function given is already proper rational function, then we are good to go. We basically saved our one extra step in which we have to go through long division, right? तो बहुत ही सिंपल कहानी है. हम रैशनल फंक्शंस को इंटीग्रेट करना चाहते हैं. आप जानते हैं रैशनल फंक्शंस क्या हैं, राइट? अब रैशनल फंक्शंस विल आइदर बी इम्प्रॉपर और दे विल बी प्रॉपर, राइट? qx is divisor. मतलब qx will be, I mean, there will be an expression like x minus 1 upon x square minus 1. Okay, so in this case qx is x square minus 1, but this is a proper rational fraction, right? So we don't need to do long division. But if let's say the question is like this, we need to integrate this. In that case, I will not start directly integrating. Here in this case, I can start directly integrating using the rules that we will discuss in a few minutes. But if this is the question, if this is the case, then I will first divide x cube minus 1 by x plus 1. I will get some quotient, right? Some remainder, right? So this fx is quotient, this gx is your remainder, and then qx is x plus 1. हाँ जी, समझ आइए ये बात शाबाश, क्लियर है? Shaviz, is it clear what is qx? Okay, cool. Yeah. So if it's a proper rational function, then we are good to go. Now let's understand how can we solve this particular form, okay? Or how can we solve these integration of rational functions? Chaliye ji, what will we do if the function given, if the rational function given is proper, then what do we need to do? चलो जी, अब यहां से आ जाइए. Start with here, right? We need to apply long division in this case. Improper rational function, proper rational function. Okay. Now, if the given rational function is proper, in that case, what do we need to do? Then start with this. Okay. Then start with this. If the given rational function becomes proper. Okay. Now, in this case, this fx is a quotient, right? Now we wanted to integrate this. Then if we integrate this, then this ye to polynomial hi hai. Fx is a polynomial, right? So fx will be your fx will be integrated directly. You will face no difficulty in integrating fx. Now again, we will also integrate gx upon qx. This is also a form of second. ठीक है? तो अगर पहले वाला केस भी आता है तो भी कोई प्रॉब्लम नहीं है. उसमें हम पहले फर्स्ट वी विल डू लॉन्ग डिवीजन. After long division, we will get something a form like this, right? And then we will integrate this. This here we will face no problem. Okay. Chalo ji. Now the target is if the given rational function becomes proper, then what do we need to do? Then step one. You factorize your denominator. Factorize the denominator part, right? Which is what? Qx, which is Qx. No, बहुत ही हल्के में मेरी बात एक और समझ लो. This Qx can be anything वैसे तो. I mean, this Qx can be of any degree, but generally this will not be of greater than 3. So your denominator will never be greater than degree 3. In 1-2 question, it might be degree 4. In 1-2 questions only, but it will never be greater than degree 3, because it will not be easy to factorize for you if the degree is greater than 3. So in the questions where the degree is 4, it will be very easy to factorize the particular polynomial. They will not give you tough expression. Okay. So you need to factorize this denominator part Qx, which has a generally its degree will be less than equal to 3 only. So don't worry, you will face not much difficulty in factorizing this Qx, right? So you will factorize this Qx. Now this Qx will be factorized in one of the form like this. Okay. This Qx can be either factorized. So now if you factorize Qx, then that can be factorized into multiple quadratic equations. Either those quadratic equations will have roots or will not have roots, right? So this px by qx, what we are talking about, this px by qx will look like this. Okay. Either this qx can be of the form of x minus a into x minus b, which means 2 distinct roots, right? Or so in this case, सर हम बहुत सिंपल सी बात बस ये बोल रहे हैं कि जब आप when you will go to factorize this qx ना, in that case qx can either be factorized into 2 separate linear, I mean, see, the degree of qx can be either 2 or 3. ठीक है? So if degree of qx is 2, or rather than that, take degree 3. I'm taking degree 3. You will not face any question which has degree greater than 3. So I'm taking the degree of qx as 3. Consider degree qx is equals to 3. Then qx can either take these 3 forms. Either it will be x minus a, x minus b, x minus c, which means 3 distinct real roots. Okay, 3 distinct real roots. In this case, your px by qx जो ये वो फंक्शन है, वो रैशनल फंक्शन है जिसको आप इंटीग्रेट करना चाहते थे स्टार्टिंग से, राइट? दिस विल बी द रैशनल फंक्शन विच वी वांटेड टू इंटीग्रेट. So this px by qx will look something like this. We don't know about px, but px will certainly have a degree lesser than qx. Okay, leave the integration sign also. Just focus on the expression, right? So if you have qx as a cubic polynomial, so either that cubic polynomial will have three distinct real roots. In that case, qx can be written as x minus a, x minus b, x minus c. And this particular expression can be written like this. I will tell you all the logics. Don't worry. रट जाएगा ये तुम्हें, इसकी टेंशन नहीं है. बस एक बार मेरी बात थोड़ा ध्यान से समझते चलो. Either qx will have three distinct roots or qx will have two distinct roots. So two distinct. Now, how will this situation be possible? First of all, two distinct roots. Two distinct roots माने one root is same. Two distinct roots माने one root is same. So it means that two factors are same. That is why two roots are same. Both the roots are a, and another root is b. So here, two distinct real roots. In this case, your px upon qx will look like this. इसको हम repeated roots की तरह भी देखते हैं. One repeated root, we can also call it like this. One repeated root and one separate root, right? So this particular expression can be written as a upon x minus a. See, because the power of x minus a is 2, so there will be two factors coming because of x minus a. One is because of x minus a power 1 and another will be because of x minus a power 2. Or third situation can be like this, that one is a real root and so only one real root and two roots are complex, which means that you cannot further factorize this quadratic equation. Right? In that case, your px by qx will look something like this. Right? And this can be written as a upon x minus a plus bx plus c divided by b1x square plus b2x plus b3. हाँ जी, लिख लिया ये. आर यू डन? तो अब मैं समझा देता हूं इसको एक बार, क्या हम बोल रहे हैं. ना ना शाविस, वी कांट फैक्टराइज दिस फर्दर. b1x square plus b2x square plus b3. अगर फैक्टराइज कर पा रहे होते तब तो ऊपर वाले दोनों केस में से कोई ना कोई बन रहा होता ना भाई. इसको फैक्टराइज कर दें अगर, तो या तो इसका फैक्टर्स ऐसा बन रहा होगा इक्वल रूट्स वाला, या फिर ऐसा बन रहा होगा कुछ डिस्टिंक्ट रूट्स वाला, या फिर तीसरा केस के फैक्टराइज हो ही नहीं रहा होगा, कॉम्प्लेक्स रूट आ रहा होगा. हाँ जी, अब एक बार मैं बता दूं. चलो पहले सिंपल सिंपल समझ लो. तो फर्स्ट ऑफ ऑल वी कैन integrate any rational function. Second is check your rational function, whether it is proper or improper. If it's improper, please convert it to proper rational function. And now let's try to integrate your proper rational function. Proper rational function means degree of numerator will be lesser than degree of denominator. Okay, ji? Now, how would we start? We would first factorize our denominator. Okay? So denominator will lead us to these three kinds of factors. Either single linear factor, x minus a type, x minus a, x minus 1, x minus 2, x minus 3, anything, but linear factor. Or a repeated factor, दूसरा ये x minus a whole square, or third is no factor. So when you factorize any polynomial, you will only get factors in these three forms, either linear or repeated. Repeated माने linear to the power 2, x minus a whole square, x minus b whole square, x minus c whole square. So either linear यानी कि power 1, x minus a power 1, or repeated माने x minus a power 2, or no factor माने your direct quadratic equation. तो आपके denominator में, your denominator will always contain these three kind of expressions. One linear, second repeated, third direct quadratic, like this. Now, if you have these kind of expressions in your denominator, then you can change that denominator. You can change or you can distribute that denominator like this rule. Now, what's the rule? Rule is pretty simple. If the power is linear, or rather than that, the factor is linear. If the factor is linear, so linear factor will take a constant and get separated. So there was one linear factor x minus a. It will take a constant. So this a is a constant, and this will get separated, a upon x minus a. Then another linear factor x minus b. So b upon x minus b. Then another linear factor which was x minus c. Then there is a constant with that, c upon x minus c. Simple. Linear factor will get separated directly with a constant. You have to find the value of this constant. I will show you how to find the value of this constant, but just first get the concept clear. तीन ही तरीके के फैक्टर से अगर लीनियर मिलता है, सीधा सीधा उठा के अलग कर दो एक कांस्टेंट के साथ, like in this case, like here also. See, this is a linear factor. क्या किया मैंने? Linear factor with a constant अलग कर दिया, c upon x minus b. एक constant दिया, put a constant with that particular linear factor and get that separated. Now, second rule, repeated factor. Repeated factor will always give you two answers. तो अगर आप repeated factor को distribute करना चाहते हैं, break करना चाहते हैं, then you will have to make two separate terms for that repeated factor. Now it's repeated, right? So if it is repeated, it will lead us to two different terms. First term single power वाली होगी हमेशा, second term double power वाली होगी हमेशा. Put a constant with both the terms, right? So if it was x minus a whole square, then I will put a constant with power 1. So मैं x minus a, put a constant with x minus a, and then put a constant with x minus a whole square, right? Third rule, if we get a factor of quadratic expression, if we are not able to factorize our quadratic expression, then what do we do? तो आप quadratic equation को भी लिख सकते हो. You can take that quadratic equation also, separate the quadratic equation with a linear expression in numerator. Separate that particular quadratic expression with a linear expression in numerator. Okay, these are three rules. बहुत ही simple. अब मैं आपको एक बार और यूज करके दिखाता हूं इसको. ठीक है, देखो अभी मैं क्या बोल रहा हूं. You will get this more when I will show you like this. So these were three rules. First of all, चलिए जी, I will show you partial fraction. So this process, okay, yeah, I would also like to tell you this. The process of Or rather than that, I should write it like this. The process of let's understand the application with an example. Okay. So for example, let's take a rational function. And what we are saying is a rational function, if you see a rational function, then you can always distribute its factors which are present in denominator. Okay. What do we mean by that? Sure. Let's understand this in more detail, right? Yeah. So first of all, is it a rational function? Please answer me quickly because we don't have much time. Is it a rational function? Yes, right? Now, is it a proper rational function? Shahid, is it a proper rational function? Yeah, I mean, it is a proper rational function because the power, I mean, the degree in numerator is 1 and the degree in denominator is 3, right? Now, what I was saying is, this is a perfect example. So, first, as soon as I see that this is a proper partial fraction, and if I wanted to integrate this particular expression, then I needed to, sorry, proper rational function, my bad. So if I wanted to integrate this function, then I will have to apply partial fraction here. And let's understand how would I apply partial fraction. But before that, just understand this concept of breaking down. Okay. If you understand this, then you got this. This is no worry, right? Shall then start. So as soon as I spot that this is a proper rational function, I can further simplify this particular expression. How? So first of all, I will try to factorize this. Take x square common here from here. So you are left with x plus 1 plus 1 x plus 1, which means that the factors are x square plus 1 and x plus 1, right? So your x minus 1 divided by x plus 1 into x square plus 1. Now, first understand, can we divide it further? Can we factorize this further? X square plus 1. How do I know? Put this x square plus 1 is equals to 0. Now, is it, can it be further factorized? No. This does not have real roots. I mean, you can also find out the d. D will be negative in this case. D will be coming out minus 4. There is no real root of this particular x square plus 1 equation, right? This cannot be further factorized now. Now, this term is a quadratic expression. And this term is a linear expression. There is no repeated root here, right? That is what I was telling you. जब भी आप factorize करोगे, whenever you will factorize the denominator, right? You will always get these kind of expressions, either linear or repeated or quadratic. Now, what do I do with linear expression? I will just take them separately with a constant a upon x plus 1. Agar if it would have been 10 linear expression here, I would have made 10 terms, each with a constant and each with that particular linear factor, right? Then second, quadratic expression. Now, what's the rule of quadratic expression? Put a linear expression in numerator, which is bx plus c, and then put the quadratic in denominator. Now we need to find out the value of a, b, and c to find out the solution of this question. Now, how would we do that? Yeah, it's easy. No worries. So how would we do that? Chalo. This is nothing but x minus 1 upon x plus 1 into x square plus 1. We need to find out what? A, B, and C. Okay. So this can be written as a into x square plus 1. So this is x plus 1 into x square plus 1. And then this would be, they will be cross multiplied. So a into x square plus 1 plus x plus 1 into bx plus c. Right. So this can be written as x minus 1. This denominator can be cancelled out both sides. This is a times x square plus 1 plus x plus 1 into bx plus c. Now you can solve this whole equation to find out the value of a, b, and c. Right? And this can be done using two ways. So first, today, I will be only teaching you the basic way or the long method, basically. So how can we solve this? We need to solve this particular equation. How? So let's multiply the whole equation first. So this is ax square plus a plus this would be bx square, right? Plus bx plus cx. So this would be b plus cx plus c, right? So this can be further written like so this is a long method, by the way, but long method says that please solve the whole left hand side and right hand side and come with the equation. Come with the equation, mane your left hand side should be a polynomial as well as your right hand side should also be a polynomial. Now you can compare the coefficients. So coefficient of x square in left hand side it is 0, in right hand side it is a plus b, right? So first equation is that your a plus b must be 0. Then second equation is your b plus c, that is the coefficient of x, must be equal to the coefficient of x in left hand side, which is 1. And third will be that your constant term must be equal to minus 1. It says that a is equals to minus b. Now it says you can put the value of b as minus a here. So this is c minus a is equals to 1. If you use this using 1, you can write minus a in place of b. So this is nothing but c minus a is equals to 1, right? And we can use c is equals to a plus 1 to solve this. Now, if you put c is equals to a plus 1 here, then your a comes out as minus 1. You can solve this. Your a comes out minus 1. If your a is minus 1, then you also get your b, which is again 1. And if you get a, then you also get b and also get c. C is 0. C is 0. So you're basically, you're this particular expression, x minus 1 upon, okay, just give me a minute. So it implies that your this expression, x minus 1 upon x square plus x cube plus x square plus x plus 1 can be further simplified to x minus 1 into x plus 1 into x square plus 1, which can be further simplified into the form of minus 1 upon x plus 1 plus x upon x square plus 1. So you put the value of a is minus 1, so minus 1 upon x plus 1, c is 0 and b is 1. So this becomes this. Now, if you wanted to integrate this, now let's say, now the question says, please integrate this. So the question is, please integrate this. To integrate this, first, we needed to solve this. We needed to take this into this form. Now this question can be pretty easy, easily handled after this point, because we also know this. This we have studied in the last class, right? We can multiply with 2 and divide by 2. So this 2x will be differentiation of x square plus 1, right? And then this minus 1 upon x plus 1 can be directly integrated. So when we see this part, this seems like unsolvable, but when we convert this into the right form, this is pretty straightforward, man. This is log of x plus 1, and then this is, again, if this is t, then this is dt. This is also log of x square plus 1 if you solve them. This is the final answer. Right? So this is how we can apply partial fraction. But before coming to next class, which is on Friday, I guess, Austin, just revise this, okay? There may be a lot of theories, but if you revise this, then we are good to go in the second class. It will be, the second class will be really nice in that case. But one thing is sure, that if you work on this part, just understand the concept of how we are breaking the denominator, which consists basically 3 rules. And